Some things work because we understand them. Others work even though we don't. They function, they produce results. They shape our world. But when scientists look closer, the explanation becomes uncomfortable. Because the deeper we go, the more it feels like we're using tools built on rules we only partially understand. These are 20 things that work even though they shouldn't. The placebo effect. Sometimes fake medicine works. Sugar pills relieve pain. Saline injections reduce symptoms. Patients improve even when the treatment contains no active ingredient. The brain can trigger real physical healing simply because it expects improvement. Belief alone can activate biological change. Medicine sometimes works, even when the medicine isn't real. GPS, relativity, corrections. Your phone's GPS relies on satellites orbiting Earth. But those satellites experience time differently because of Einstein's relativity. Without correcting for time distortion caused by gravity and speed, GPS would drift kilometers off target every day. Modern navigation works because engineers constantly adjust for the fact that time itself flows differently in orbit. The bumblebee flight problem. For years, early aerodynamic models suggested bumblebees shouldn't be able to fly. Their wings seemed too small for their body weight. Later research revealed that bees use chaotic wing movements that create complex vortices. Flight still works, just not the way scientists originally expected. Antibiotics from mold. One of humanity's most powerful medicines came from a contaminated lab dish. When mold accidentally grew on a bacterial culture, it killed the bacteria around it. That mold became penicillin, discovered by Alexander Fleming. A random accident led to antibiotics that saved hundreds of millions of lives. Wi-Fi signal penetration. Wireless internet travels through walls, furniture, and sometimes entire buildings. Radio waves scatter, reflect, and interfere with each other constantly. Yet somehow, your device still reconstructs a clean signal. It works through a chaotic environment that should destroy the information. The immune system's memory. Your immune system can remember viruses it encountered decades ago. Certain immune cells survive for extremely long periods, holding molecular memories of past infections. Your body keeps a biological archive of threats it may never encounter again. A living database. Inside your blood, quantum tunneling. At the quantum level, particles can pass through barriers they should never cross. They simply appear on the other side. This phenomenon is called quantum tunneling. Without it, the nuclear reactions powering stars, including our sun, would not occur. The universe runs on particles, occasionally ignoring walls. Deep neural networks. Modern AI systems can perform complex tasks like recognizing faces or writing text. But often, researchers cannot fully explain how the network arrived at its answer. The system works, yet the internal reasoning remains partially hidden inside millions of interacting parameters. Machines solving problems. Without clear explanations, the human brain's pattern detection. Humans can recognize faces in a fraction of a second, even with partial images, shadows, or distortions. Your brain identifies patterns with incredible speed, but neuroscientists still struggle to fully explain how billions of neurons coordinate that recognition instantly. The stability of the proton. Atoms rely on protons staying stable. According to some physics models, protons should slowly decay, yet experiments have never observed one breaking down. If proton stability failed, matter itself would dissolve. Reality continues working, even though theory keeps expecting otherwise. Photosynthesis, efficiency. Plants convert sunlight into chemical energy through photosynthesis. At the molecular level, energy travels through protein structures with surprising efficiency. Some studies suggest quantum effects help guide energy along the most efficient path. Plants may be using physics that resembles quantum optimization. Evolution, finding solutions. Natural selection produces structures like eyes, wings, and complex nervous systems. These systems require many interacting components. Yet evolution builds them step by step without planning. Random mutation plus survival pressure somehow constructs extraordinary biological machinery. The internet itself. The internet routes billions of packets of data every second. Signals travel through thousands of independent networks. Routers constantly adjust to failures, congestion, and broken connections. Despite enormous complexity, the system rarely collapses. A global machine held together by decentralized cooperation. Superconductivity. Certain materials conduct electricity with zero resistance at low temperatures. This phenomenon, known as superconductivity, allows current to flow indefinitely. Some forms of superconductivity still lack complete theoretical explanations. Electricity flows perfectly, under conditions we don't fully understand. The stability of planetary orbits. Gravity constantly pulls celestial bodies in complex directions, yet planets maintain stable orbits for billions of years. Small changes could lead to chaos. But the solar system remains balanced through an intricate gravitational dance. Memory storage in the brain. Scientists still debate exactly how memories are stored in neural circuits. Memories survive injury, chemical changes, and even neuron loss. Your brain retains decades of experiences using mechanisms that remain only partially mapped. The effectiveness of vaccines. Vaccines train the immune system to recognize threats before they appear. Tiny fragments of a virus can prepare the body to fight the real infection. The immune system reacts faster, stronger, and more efficiently. A microscopic preview of danger becomes long-term protection. Random mutation creating complex life. Life evolves through random genetic changes filtered by survival, but over billions of years, this process built organisms capable of thought, language, and technology. Complex intelligence emerging from blind mutation still feels improbable. Yet here we are, dark energy. Astronomers discovered the universe is expanding faster over time. Something invisible is pushing galaxies apart. This mysterious force is called dark energy. It makes up most of the universe, and scientists still don't know what it is. Consciousness. The human brain contains around 86 billion neurons. Electrical signals travel between them constantly. Somehow, this activity produces awareness, thought, experience, identity. No scientific theory fully explains how physical matter becomes subjective experience, yet every moment of your life proves that it does. Science explains an incredible amount about the world, but some things still function at the edge of understanding. They work reliably, they shape reality. Yet the deeper we investigate, the more questions appear. Sometimes the most unsettling discoveries are not the things that fail, but the things that keep working, even though they shouldn't.